Okay, here we go. This is the video for Unit 5, Quiz 4, which covers Lesson 10, 11, and 12. So drawing solids. Draw two solids that are not identical but have the same volume. Now on this one requires a lot of creativity. So if you just copy my answer, I'm not going to be thrilled. So I need you to come up with your own example and not use mine from this video. However, I'll help you on this. So two solids that are not identical but have the same volume. So let me get up to the front board and here we go. Okay, so two solids, not identical, but have the same volume. In my opinion, I like to start with a cylinder. So go with a cylinder. Versus a prism. So a cylinder versus a prism. This is just my idea. This is Fisher's example. You have so many options on this problem, but for whatever reason, I've always liked comparing a cylinder versus a prism. But you could compare really any two solids. It doesn't have to be cylinder and prism. So here we go. A cylinder versus a prism. I'm gonna do what's called a right cylinder. That just means it's like standing upright as opposed to oblique, which is tilted. So let me start with the radius for precision. So I'm gonna do So I'm going to do a radius on my cylinder of 10 centimeters. Clean up my work a little bit. Okay. So now we have a cylinder with a circular base, and the radius is 10 centimeters. Okay. Now, the height of my cylinder is 20 centimeters. I actually used a ruler. Now, you can create a cylinder of really any size by using like a ruler right here. Now, you got to compute the volume. So the volume is pi r squared times height. So for this one, it's pi 10 squared times 20, which equals 100 pi times 20, which equals 2 times 100 is 200 plus a 0, 2,000 pi centimeters cubed. So this volume is 2,000 pi cubic centimeters. So now, a prism's volume is length times width times height. Now I know it's going to be 2,000 pi will equal length times width times height. So let's factor out 2,000 pi. The first two factors that I quickly see are 2,000 and pi. Now I know I need three things in the prism. I need length, width, and height. So why don't we break this out into let's go 500 and 40. 5 times 4, 20. Nope. Let's do 50 and 40. Jeez. A little off today. 50 times 40 is 2,000. Whoops. Okay, so I have my measurements. You've got a length, a width, and a height. Because multiplication is communicative, you can make this the length, width, height, or you can make this the height, this the length, this the width, whatever. Length is typically the longest one. Width is usually in a prism like this. It usually breaks down like this. Length, width, height. 50 is the biggest, 40 is the next. Pi is 3.14, so we can make this either width or height. But anyway, I don't want to get too sidetracked here. So let me draw a prism with 50, 40, and 3.14. Let me just see how I could do that. All right, I'm just gonna make a little thing. This is not to scale. Not to scale, but here we go. Only got 1 minute. Okay, so we now have a prism. We're gonna call this 50, 40, and pi. You now have a prism, 50 centimeters by 40 centimeters by pi centimeters. This volume also equals 2,000 pi cubic centimeters. Now, if this was drawn to scale, it would have about the same volume as this cylinder. So 20, 50 would have been up here. So it would have been a tall one. And it would have been about this wide. Would have been a really tall, like huge face, but then a tiny, 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 tiny width. So anyway, that is an example. Please don't use mine. And on to the next. Let me just erase. Okay, here we go. Try to keep this under 30 minutes. All right. In the solid pictured, the cylinder, the whole thing, has a radius of 4 centimeters and a height of 10. I don't see a radius pictured, so I'm just going to draw it. So here's your radius, also equals 4. I like to label my drawings in helpful ways. So the height's 10 centimeters. There's a hole in this cylinder that's in the shape of a square prism. So you can see this white space right here. That's in the shape of a square prism. That's like, if you look at like a socket wrench set, you'll see the attachments have this kind of shape. But anyway, the base of the prism has side lengths of 4. Now because it's a square prism, you know that this is 4 too. So is this, so is this, because it's a square as a base. Calculate the volume of the solid. Round your answer to the nearest tenth. Tenth is 1 decimal. So there, we've dissected the directions. Now let's figure it out. If there's a hole in the middle of the cylinder, that means we have to get the whole cylinder's volume and subtract the prism's volume. So the game plan on this one is the volume of the cylinder minus the volume of the prism. So underline these two. So volume of the cylinder minus the volume of the prism. That's how you get this one. The volume of the cylinder is pi r squared times height. The volume of a prism is length times width times height. Now we are going to input what we know. So we know R and we know H. R equals 4, H equals 10. Over here, we know L equals 4, W equals 4, H equals 10. So this one's pretty easy. We are given everything. There's nothing new we have to figure out. So we just got to input the numbers. So we're going to say volume equals pi 4 squared times height, which is 10. Over here, we're going to say volume equals 4 times 4 times 10. So 4 times 4 times 10. Let's compute these. This equals pi times 16 times 10. This one equals 16 times 10. We'll just keep it going. So this one is going to be 16 times 10 is 160. Don't forget about the pi. And this one, 16 times 10 is 160. So you now have the volume of the cylinder and the volume of the prism. So what we're going to do is just go volume of the solid equals, remember, cylinder volume minus prism volume. So 160 pi minus 160. Now, don't forget about this right here. You got to round that to the nearest tenth. So what do I do here? Shoot, 160 pi minus 160. You could be like, all right, could factor out a 160 and then go times pi minus 1, but that's just kind of silly. That would have been 160 minus, or 160 times 2.14. But that's silly. So what you want to do is just go to your calculator. So get one of these Texas Instruments TI-30X 2S calculators or any of the other ones. Turn it on, clear out previous work so you got a clean slate. 160 pi minus 160 equals 342.6548. 342.6548. Triple check. Yep, that's what we got. But you got to go one decimal place because that's what tenth means. So your volume, this is going to be your final answer, is 342.65 goes to 0.7. Don't forget your unit of measurement, centimeters. Since we're talking volume, it has to be to the third power, which means that the volume of the solid is 342.7 cubic centimeters. Hey, bought us some time. That only took 7 minutes. All right. So there it is. If you want to pause the screen so you can see the work, or pause the video, I should say. Pause the screen. Pause the video. Look at all this work. If you notice, it's very clearly, I can grade this work very easily because I know that the steps are one by one in order. At the tail end, I went over here. But on your cool down, you'll have plenty of space. So just clearly organize your work on this one, or else it gets too much to think about. All right, next question. Lesson 12. Just going to start the timer now. Better erase the board. Now, some people might wonder, why do I give you the questions ahead of time? Well, they actually do that on the CSET that math teachers have to pass. So when you're going to get your credential, they'll give you like 200 questions to study from, and then when you go and take the big test, there's like 36 that you gotta nail. So if they're letting teachers have a glimpse into the questions, why can't we let the students have a glimpse into the questions too? So I'm not trying to hit you with gotcha questions. I just want to know that you know the concepts in order to show your work. So math can be really challenging. I understand. But anyway, here we go. Lesson 12, prisms and pyramids. Number one is, this is a tough problem because you don't have any figures. So, but number one says, how many faces does a right triangular prism have? And then it says, what are the shapes? So what shapes of the faces? Right? Okay. So how many faces does a right triangular prism have? Well, let's see. Why don't we draw one? Draw one. So a right triangular prism. Well, you gotta be able to imagine what a right triangular prism is. Here's a prop for you. There's a right triangle with congruent bases. I already know how many sides it is because I know this is a right triangular prism. It's from my skate park. You'll start to notice everything in my classroom is a prop. But let's draw one. So a right triangular prism. Okay. Start with your right triangle. Does it have to be perfect? Nope. Try to get close though. That'll help you. Alright, so you got your two bases, which we're going to say are congruent. And you just connect this point to this, this to this, and this to this. Okay, now we have a right triangular prism. So how many? They need a number. Well, you got your two bases, which we already talked about. We got this third one, which is a rectangle. You got this fourth one right here, these two. And then if you look real closely, there's a fifth, which we might say is on the bottom. Right? So 1, 2, 3, 4, 5. So how many? There are 5. Faces on a right triangular prism. Now, one of the key parts of geometry is like using your white space and thinking about how much white space you have so that you can like continue to have clean work. You don't want to be too sloppy. So I know that I can answer this question right here. And there's a second question. What are the shapes of the faces? Well, 1 and 2 are right triangles. Three, 4, and 5 rectangles. Cool. Number 1 is done. Math is fun, right? Okay, how many faces does an oblique triangular prism have? So, okay, oblique triangular prism. Notice they did not say right, so you don't necessarily need right triangles. But here's like a oblique triangular prism. It's not like straight up and down, basically. So there's a regular or an upright triangular prism. That one is oblique. So the faces make angles, like basically the faces make angles with the bases. So here's the difference. The angles are a little bit different. So that's what an oblique triangular prism is. So, how many faces does it have? Well, let's find out. You still have 2 triangles, right? That's a rectangle, and then another one on the bottom. So, how many faces? 5. What are the shapes of the faces? 2 triangles. So, triangle. It's not specified that it's a right triangular prism, so you can just say triangle. And you can say triangle. And then you have 3 rectangles. So you got 2 triangles, 3 rectangles. Okay, how many faces does a triangular pyramid have? So it's a pyramid, which means there's an apex, and it's a triangular pyramid, so the base is a triangle. And then what are the shapes? So I'm going to work up here for this one. I'm going to use some different color just so we don't confuse it with this. Color code your work, trust me. All right, triangular pyramid. So you got a triangle. You know what a triangle is. That's the base. And then you've got an apex. We'll just call it right here. So there's your apex. Connect each vertex to the apex. There is a triangular pyramid. How many faces? This is where you count them. You got 1, 2, that little one, 3, this one, and then if you look closely, there's a big 4th triangle. So I see 4 faces. 4 faces. What are the shapes? All triangles. Four faces, all triangles. There's 3 cooldowns, 3 quiz questions. It's a tough quiz. If you don't finish in time, there's a did not finish pile, but it's on you to come finish it. I know, I just worked for 30 minutes. So there's never any time limit on my tests, but you got to come in at lunch or come in after school to finish it. I'm not going to track down 140 people. That's on you. So anyway, you got all the answers. You got a video. You can watch this video as many times as it takes for it to click. And just keep trying your hardest. And if you try your hardest and you still can't get the answers, just come see me. I got you. That's what I love to do, is help people. So anyway, there it is. Good job, and I'll see you next time.